Dear students, in this video we are discussing Physics Term 2 examination for grade 9 advanced, and we will be discussing all the 20 questions given in the EOT in the order of question number 1 to 20 as given in the EOT end of term examination. First of all, thank you for watching this video, and I have one request. You can share this video to your friends and classmates. So we will start with the first question. Question number 1. Explain motion of horizontally launched projectile and show schematically the components of velocity and acceleration throughout the motion. So first question, EOT question number 1, that is about horizontal projectile motion. Question is about horizontal projectile motion. And we need to study question number 7 and question number 8. Question number 7 and question number 8 from page number 147 of your textbook, page number 147 of the textbook. So firstly, what is horizontal projectile motion? It is simple, like you are throwing an object in the horizontal direction. You are not throwing like this at an angle. You are not dropping vertically downwards. You are throwing an object in the horizontal direction. So what is horizontal projectile motion? Horizontal projectile motion is throwing any object, for example this marker, throwing an object in the horizontal direction. Throwing an object in the horizontal direction, that is called horizontal projectile motion. So if I throw this marker, and when the marker leaves my hand, the marker is a projectile. Then this object, the object we are throwing is called projectile. It is called a projectile. If I throw this marker is the projectile. If I throw this duster is the projectile. If I throw this calculator, then calculator is the projectile. Okay. The next, so what happens if I throw? You are on the top of this building. You are here, where you are here on the top of the building, and this is the ground. You are throwing a ball from here. You are throwing the ball in the horizontal direction from the top of the building. You are throwing like this. So this will be a horizontal projectile motion, and the ball will follow a path like this, right? The path of the ball will look like this. It will be moving like that. So here you can see the ball was initially here, and finally the ball will reach here. So the ball is moving a downward distance, right? The ball is moving a downward distance. At the same time, the ball is moving a horizontal distance also. The ball is moving to the right side, at the same time downward, right? If it is moving only downward, then the ball will reach here. If it is moving only in the horizontal direction, the ball should reach here. The ball is actually reaching here, means it has a horizontal displacement, it has a vertical displacement and a horizontal displacement. So the ball or the projectile has both horizontal and vertical motion at same time. So a projectile is any object that you are throwing, and horizontal projectile motion means you are throwing it in a horizontal direction. And the second point, every projectile has both horizontal means along the x direction, x axis, and vertical motion. A projectile has always motion along the horizontal direction and vertical direction. A projectile has both horizontal and vertical. Vertical means along the y axis motion, which means a projectile has horizontal velocity and vertical velocity. So at the beginning you are throwing it in a horizontal direction. So at the beginning it has only horizontal velocity. Its vertical velocity is 0. So at the start, at the beginning, okay, at the starting point, at the start, it has only Vx. It has only Vx, that is equal to, means with what velocity you are throwing. So I will write the given velocity, how much velocity you are giving to the marker. So horizontal velocity Vx is equal to given velocity, and vertical velocity Vy is equal to 0, means when you throw it at the beginning, because you are throwing it in a horizontal direction. Then we will now, that is about the velocity. Now we will talk about the force. See, when you throw, you are applying a force. So when you apply the force and the ball is leaving your hand, right? So the marker is leaving the hand. After it left my hand, I am not applying any force. See, first we are giving an initial velocity by applying a force. After that, I am not applying the force. There is only one force acting on the object. There is only one force acting on the projectile. We will ignore the air resistance, okay? Ignore the air resistance. So after ignoring the air resistance, there is only one force acting on the projectile, that is force of gravity. So what is a projectile? A projectile has given an initial velocity, and after that only one force is acting on the object, that is the force of gravity. So a projectile is moving only on force of gravity. The only one force, the only force acting on the projectile is what? Force of gravity. Force of gravity I will represent by Fg. Force of gravity is the only force acting on the projectile. What is the direction of force of gravity? Upward? Never. Force of gravity will be always act vertically downwards. The direction of force of gravity is always downwards. Always downwards. So there is only one force acting on the projectile. Force of gravity. What is the direction? Downwards. So that is about the force, okay? On this object, after throwing, the object will reach here. The object, after some time, the object will reach here. After some time, it will reach here. And finally, it will reach here, right? So at all the points, there is only one force acting on the projectile. Force of gravity. Only one force is acting on the projectile, right? Force of gravity. During its motion, will force of gravity increase? Will it decrease? Or will it be same? That we know that force of gravity is equal to mg. So during the motion of the ball, the mass of the ball is not changing. The gravitational field of Earth is not changing. So force of gravity will not change. That is why we will draw same length for the force of gravity. Okay, force of gravity. Force of gravity means the weight of the ball, the weight of the object is the only force acting on the object while it is in the air. So that is about the force of gravity. Number one, there is only one force acting on the projectile, that is force of gravity, means its weight of the object. What is the direction? downward, and throughout the motion force of gravity will be same, it will not change. Force of gravity depends on the mass of the object, so during the motion mass of the ball is not changing, so force of gravity will not change. Okay, so we talked about the force. Next we will talk about the acceleration. After talking about the force, we will talk about acceleration. So about acceleration, we can say acceleration is the product of force or net force. Acceleration is the child of net force. If net force is in the downward direction, acceleration will be in the downward direction. If net force is in the upward direction, acceleration will be in the upward direction. If net force is increasing, acceleration will be increasing. If it is decreasing, acceleration decreasing. If net force is constant, acceleration will be constant. So acceleration, it is the child of or the product of net force. Product of net force. So acceleration is from net force. So here we can see there is only one force acting on the projectile. So that is the net force. What is the net force here? Net force is force of gravity. In which direction? Downward. So if net force is downward, acceleration in which direction? Acceleration also downward. We know that net force means force of gravity mg is constant. Acceleration is the product of net force. If net force is constant, acceleration will be also constant. So if we draw the acceleration of the projectile, schematic diagram, right? We are showing the direction of the acceleration by drawing. So acceleration will be in the downward direction, that will be equal to acceleration due to gravity. So acceleration will be always equal to g, right? Okay. Anyway, acceleration we can write a or g. Here acceleration is equal to acceleration due to gravity g. I will represent acceleration by the letter a. Direction is downward, everywhere direction downward, and the value of the acceleration or magnitude of the acceleration will be constant throughout the motion. So draw line with the same length, equal length, acceleration, acceleration. Okay, so we talked about acceleration. We discussed first about the net force, means about the force acting on the projectile, and about the acceleration of the projectile. Next we will talk about the velocity of the projectile. Okay, velocity of the projectile. We will talk about the velocity of the projectile. So first I said projectile has both horizontal motion and vertical motion. It is at the same time. The object, the projectile means the object you are throwing is moving in horizontal direction and vertical direction at same time. So a projectile has horizontal velocity, that we will write vx. Horizontal means along the x direction, and it has vertical velocity vy. Then at the start means when you throw it. So at the starting point, its horizontal velocity, that is equal to the velocity at which you are throwing the object, means how much velocity you are giving to the object. So initial at the starting, horizontal velocity is equal to how much velocity you are given. So I will write a given velocity. Vertical velocity is equal to 0. So after the marker leave, after the ball leave from your hand, there is only one force acting, that is in the downward direction. So because of that force, its vertical velocity, means its downward velocity, was initially 0, right? So now we will talk about the velocity. Okay, we will draw about the velocity, acceleration. Now you can move, you can go away. Yes, Now our velocity will come. So at the beginning there is no velocity in the vertical direction, so Vy is equal to 0, and because of the weight of the object, because of the force of gravity is pulling the ball downwards, right? So because of that it will have a vertical velocity Vy. See, there is force acting in the downward direction. Whenever there is a force, there will be acceleration. If there is a net force, there will be acceleration. There is a net force in the downward direction, there will be acceleration in the downward direction. If there is a net force, there is acceleration. So here there is acceleration in the downward direction, right? That we have already discussed about the acceleration. There is acceleration in the downward direction. The value of the acceleration is equal to acceleration due to gravity 9.81. The value of this acceleration is A is equal to G, right? What is the value of G? 9.81 meter per second squared. Okay. So because of that acceleration, what's the meaning of acceleration? If there is acceleration, velocity will be increasing. So its velocity will be increasing. Too much? Velocity will be increasing. Velocity will be increasing. Okay. So here, not after reaching the ground. Okay. Here I am drawing before just to touch the ball, just to touch the ground. Before the ball, just to touch the ground. So its vertical velocities keep on increasing. Is there any force in the horizontal direction? There is no force, right? No force. No force in horizontal direction. Why there is no force? Because there is only one force acting on the projectile, that is force of gravity, and it is acting downwards. So there is no force in the horizontal direction. If there is no force, no force means no acceleration. No force is equal to no acceleration. If there is no net force, no acceleration. If no acceleration means, what is the meaning of no acceleration? No acceleration means constant velocity. Constant velocity. Velocity is not changing. There is no force acting in the horizontal direction. So the velocity along the horizontal direction will be constant throughout the motion. Constant throughout the motion. Constant throughout the motion. But equal to what? Equal to the given velocity. The velocity at which you are throwing the object, equal to given velocity. Given velocity. Given velocity. If, for example, I am throwing this marker with a 5 meter per second, its velocity along the horizontal direction will be 5 meter per second. Vx is equal to 5 meter per second throughout the motion. So explain the motion of horizontally launched projectile and show schematically the components of velocity. It has horizontal and vertical component and acceleration. Okay, so we have done that, and now we need to discuss two questions, question number 7 and question number 8 from page number 147. So what is question number 7? Question number 7 is, for example, a baseball. Here is the batter, means a person with the bat. So for example, we can say this is the strike zone. From here to here I will mark as strike zone. So this is his knee. This point is his knee. Okay. So he is batting like that. So you are throwing the ball. You are throwing the ball from here. So the question is, one ball that you are throwing means that you are throwing faster. So when you throw the ball faster, it is reaching the strike zone. When you throw the ball, you are throwing the second ball from here, same place, and that you are throwing slowly. We will use another color. Slowly. So it is hitting under the knee. Too much? Okay, it is hitting under the knee. Why? So you can see here, the means it is traveling downward distance, right? More downward distance. This is the ball you are throwing slowly. This one is slow and this one is fast. So how much downward distance it to travel? The downward distance it to travel is this red one traveling this much downward distance, right? Yeah, this much downward distance, and this one is traveling only this much downward distance. So the question is, why the slow one is reaching the knee? So means the downward distance traveled, right? The ball you are throwing slowly, it is traveling more distance downward, right? That is why it is reaching under the knee. So the downward distance traveled, downward distance means vertical distance, okay? Downward distance means vertical distance traveled depends on what? It depends on the downward distance traveled depends on time. Depends on time taken. Time taken. T-I-M-E. Time taken. It depends on time taken. If the ball take more time to reach the batter, it will travel more distance downward. Okay, so if the ball take more time, to reach the batter, it will travel more distance in the downward direction. Okay, more time is equal to more vertical distance or more downward distance. Okay, so how we will connect this with the question? I gave 2 points, right? First one, the downward distance traveled by the ball depends on time. How does it depend on time? More time. If it take more time to reach the batter, it will travel more distance. So more time is equal to more distance in the downward direction, or more downward distance, more vertical distance, everything is same. So see, the ball you are throwing faster will take less time to reach the batter. Faster will take less time, right? The ball you are throwing faster because it is moving faster, right? So if you run faster, you will take less time. Faster ball means ball you are throwing faster, take less time, right? Less time. What is the meaning of less time? Less time is equal to less downward distance. Less time is less downward distance. Downward, right? Correct? Distance. Yeah, that is why it is reaching the strike zone. When it reaches the batter, it is hitting the strike zone. And the slow one, the ball means the ball you are throwing slowly will take more time. What is the meaning of more time? More time is more downward distance. Number 1. Okay, so question number 7 we have done. Then we will go to question number 8. So there is a table here. On this table there is an ice cube. Ice cube on the table, there is no friction. on the table. So ice cube is moving at a constant velocity. Ice cube is moving at a constant velocity. Question 8, yeah. A free body diagram, an ice cube slides without friction across a table at a constant velocity. It slides off the table and lands on the floor. Draw free body diagram of the ice cube at 2 points on the table and when it is in the air. So this ice cube will move like this and it will fall right off. So when it is falling, I will draw the free body diagram. So it will be moving like this, right, its path. So ice block is reaching here. So this is our ground. This is the ground. So this is the path of the ice block. It will reach there. So ice block is finally here. Okay. So we have to draw. First we will draw the free body diagram. What is the meaning of free body diagram? Free body. What is the meaning of free? Different meaning here. Free body diagram. So in free body diagram, we draw forces. In free body diagram, we draw force. How to draw force? Just by drawing arrow. Draw force by what? By drawing arrow. How arrow represent force? Length of the arrow represent size of the force or magnitude of the force. Length of the arrow is equal to what? Is equal to magnitude of the force. Magnitude means size of the force. And the arrowhead, right? The arrowhead, which represent the arrowhead. So I will write head of the arrow. That represents the direction of the force. So this is free body diagram, and when we are drawing free body diagram, we will consider the system, or we will represent the system by a dot. We will represent the system by a dot. What is the meaning of system? System is the object that is experiencing the force. So here we are studying, or the force is means we are drawing the force acting on the ice block. So here the ice block or the ice cube is the system. So when it is on the table, when the ice block is on the table, what are the forces acting on the ice block? One of the forces that act everywhere, okay? On every object this force act. Whenever they ask anything to draw free body diagram, first to draw this force. That is force of gravity. Means weight of the ice cube. Then the table will push the ice block upward, right? The table will push the ice block upward. That is the normal force. So everywhere these two forces will be usually there. Normal force, normal force. So if you want to write a system and agent, then how do we write force? What is force of gravity? Force we will represent by the letter F. Then we will write the name of the agent. Who is applying this force? Earth is applying the force. So F, force applied by Earth. On, we will write the name of the system, means the object which is experiencing the force. So here, who is experiencing the force, or what is experiencing the force? The ice block is experiencing the ice cube, right? Ice cube. Okay, yes. Normal force. How to write as system and agent? We will represent force by the letter F. Now we will write a subscript. What does subscript represent? The subscript represent agent on system. First agent in alphabetic order, okay? Agent on system. What is the meaning of agent? Agent is the person, or agent is the cause which is applying the force. Agent is applying the force. So here what is the normal force? What is applying the force? Table is applying the force. So F table. On what? On what? What is experiencing the force? The ice cube. So F table on ice cube. So here you can see both the forces are acting on the ice cube. F earth on ice cube, F table on ice cube. Both the forces are acting on ice cube. So this is how we draw the free body diagram of the ice cube on the table. Then when the table means when ice cube is in the air, for example, when the ice cube is here, when it is in the air, when it is falling, while the ice cube is falling, still the gravity, force of gravity will be acting, Fg will be acting, but it is not on any surface, it is in the air, it is not on the table. So normal force will be acting if the object is on a surface, if the object is on another object, on the surface of another object. Now the ice cube is falling through the air, it is in the air, it is not on any surface, so there is no normal force, there is no normal force. Okay, so this is all about the free body diagram. Now we will draw the motion diagram. So I will just erase this one. We will draw the motion diagram. So on the table, okay, so first we are drawing when the ice cube is on table, how is the motion diagram? It is moving at a constant speed, right? The ice cube is moving at a constant speed. How do we know it's moving at a constant speed? That is given in the question. That is given in the question that the ice cube is moving at a constant speed. So you know that, right? If it is moving at a constant speed, how? Equal separation, okay? Equal separation. Now we will just draw the velocity. Velocity only in the horizontal direction. Constant velocity, right? So constant velocity. Vx, constant velocity. The length is same. The separation between the dot, what does this dot represent? The dot represents system, ice cube. Then in the air, while falling in the air, when the ice cube is in the air, how to draw the free body diagram? So in the air, for example, it is moving like this, right? A curved path, right? In the air, it will follow a curved path like projectile, right? It is moving, and so it will have an initial velocity in the horizontal direction. So it will follow a curved path. So we will draw like 3 points here. It will have horizontal velocity and vertical velocity. You know that, right? Now it is a projectile. Same length, okay? So here I don't have space to increase the length. So horizontal velocity will be with the same length. Vertical velocity is increasing. So initially vertical velocity less, vertical velocity increasing. So this is how we draw the motion diagram while the ice cube is falling. So we have done with the EOT question number 1. Question number 2 is about friction. Define friction. Friction force as a type of force between two touching surfaces and determine its direction. So question number 2 is about friction. So what is friction? Friction is opposing force. So friction opposes the motion, right? So we can say friction is against the motion. Against the motion. If an object is moving over the surface of the other, then there will be an opposing force between the surfaces in contact. That force is called the frictional force. So what is the direction of friction? Direction of friction will be always opposite to direction of motion. Frictional force will be always opposite to the direction of motion. What else? What about the unit of frictional force? Unit of every force is Newton. Then what about types of friction? So we have two types of friction. Static friction and kinetic friction. Static friction and kinetic friction. So what is the meaning of static? Electrostatic. Static means rest, right? Static means rest. Rest means not moving. So what is the meaning of static friction? Static friction means friction acting while the object is not moving. Friction while object is not moving. While object is not moving. The frictional force acting when the object is at rest. The object didn't start its motion. That is called static friction. What's the meaning of kinetic? Kinetic means motion. Kinetic friction means friction acting on an object while it is moving. While the object is moving. That is called kinetic friction. How does friction act if the object didn't start moving? For example, there is a couch. So like there is a couch, you are not applying any force on the couch, you are just looking at this. The couch is not moving, it is at rest. So there is no static friction acting. Okay, means you are not applying the force, you are not pushing the couch, you are not pushing, right? Not applying force, not applying any force on the couch. If you are not applying any force, if there is no applied force, no friction, no static friction. Then what you are doing? Now you are going and pushing the couch. It's not moving. The couch is not moving. Why? You are applying the force, still the couch is not moving. The reason is, when you apply the force, when you start applying the force, static friction start to act. Where? In between the floor and the couch. In between the floor and the couch, the static friction start acting. If you apply, means if you increase your force, if you push it stronger, static friction also becomes stronger. If you increase your force, static friction will also increase. So how will the couch move? The couch moves because the static friction can increase up to a limit. Static friction can increase up to a limit, until a limit. Static friction can increase from 0 to a maximum value. Means there is a maximum value for the static friction. After that it cannot increase. Okay, from 0 to a maximum. This maximum is called maximum static friction. This maximum is called maximum static friction. So static friction means when you push it harder, static friction will increase. It will balance your applied force. The couch will not move. Now you will increase your force. You will push it harder. If your applied force is greater, if your applied force overcome the maximum value of the static friction, the maximum limit of the static friction, the couch will start moving. Because the applied force, the force you applied is now greater than the maximum value of the static friction. Will friction acting while the couch moving? Yes. Still the friction will be acting when the couch is moving, when the object is moving. That friction is called what? That friction is called kinetic friction. So this is about the static friction and kinetic friction. So we have done with question number 2, and now we will move to question number 3. Question number 3, recall that for an object to be in equilibrium, the net force acting on the object should be 0. So equilibrium, right? We are talking about equilibrium. So if any object is in equilibrium, equilibrium means there is no net force acting on the object, right? Forces are balanced. For example, there is a box here. You are applying a 2 Newton force. Your friend is applying a 2 Newton force in the other direction. What is the net force acting? 4 Newton or 0? 0. Why? Because forces are in the opposite direction. So net force is 0. If net force acting on the object is 0, we say the object is in equilibrium. Now this box is in equilibrium. So equilibrium means F net force acting on the object is equal to 0. If net force acting on the object is 0, then what about the acceleration of the object? We said acceleration is the child of the net force. If net force is 0, acceleration will be 0. If acceleration is 0, what happened to the object? If acceleration of the object is 0, the object will be either at rest or the object will be moving at a constant velocity, uniform motion. If the acceleration of the object is 0, the object will be at rest or constant velocity. How do we know the object is in equilibrium? We know the object is in equilibrium if the object is at rest or moving at a constant velocity. If any object is at rest, means stationary, the object is in equilibrium. If any object is moving at a steady speed, means constant speed, the object is in equilibrium. So which object is not, if they means the object at rest is in equilibrium, the object in motion also in equilibrium. So which object is not in equilibrium? The object moving with an acceleration, means if the velocity of the object is changing, the object is not in equilibrium. Velocity changing means it may be speeding up or it may be changing the direction. For example, object is moving at a constant speed along a circular path. Speed is constant but direction is changing. Direction changing, velocity changing, so velocity is not in equilibrium. Sorry, velocity is not constant, it is accelerating, right? So which object is not in equilibrium? The object that is moving with an acceleration. So non-equilibrium or not in equilibrium. Not in equilibrium means it has an acceleration. There is an acceleration. Acceleration of the object is not equal to 0. If the object acceleration is not equal to 0, we say the object is not in equilibrium. Okay. So if the object is at rest or in motion, the object is in equilibrium. Okay. Then I will give you one example here. So we have two forces. This is our first force, 4 Newton force, and we have a second force, a 3 Newton force. What is the net force? So there are two forces acting on this object here. There is an object here. On this object, two forces are acting. One force is acting to the right side, 4 Newton. Another force is acting to the north side, 3 Newton. Is the object in equilibrium? No, because there is a net force, right? And you know how to calculate the net force. You know how to use the Pythagorean theorem, right, to calculate the net force. So you will calculate the net force. So its net force will be along this direction, right? Net force will be always from the starting to the end, starting of the vector diagram to the end, right? Okay. So what will be the value of the net force? Net force will be 5 Newton. Net force is equal to 5 Newton. So that is called the resultant, right? The resultant force. The resultant is 5 Newton. Resultant will be 5 Newton. Resultant of what? Resultant of this 4 Newton and 3 Newton force. Now for example, yeah, what is the direction of the resultant? Yeah, this is the direction of the resultant. Now for example, you are applying a third force on the object. A third force on the object. That third force is equal to the resultant. Resultant was 5 Newton, right? Equal to the resultant but opposite to the resultant. Opposite in direction to the resultant. The force that is equal to resultant. Equal to resultant. In opposite direction, right? In opposite direction is called what? What's the name of that force? That force is called equilibrant. Equilibrant. Okay. So now there are 3 forces acting. 4 Newton force acting to this side, 3 Newton force acting to this side, 5 Newton force is acting to this side. That 5 Newton force is actually equal to the resultant force but opposite in direction. So now all forces are balanced. Now the object will be in equilibrium. What do I want to tell? I want to tell that, like for example, if you draw a vector diagram like this. So this is a vector diagram, right? See the arrow going like this, like this, like this. So it is a closed loop, right? Closed loop. See the arrow? A closed vector diagram represent the net force is 0 and the object is in equilibrium. So a closed vector diagram shows the object is in equilibrium. So we are done with the question number 3. Question number 4 is about solve problems related to friction, and we need to solve question number 19 and 20 from page number 127 of the textbook. To solve problems related to friction, first we will talk about the equations to calculate friction. So first equation to calculate friction, frictional force we will represent like this: force of friction. Okay, force of friction, that we will represent in that way. So first equation to calculate friction is equal to coefficient of friction multiplied normal force. N is normal force and mu is the coefficient of friction. So what is FF? Frictional force. Okay, frictional force, that is equal to coefficient of friction multiplied normal force. So here what is normal force? Normal force, for example, if the surface is a horizontal surface, if the object is on a horizontal surface, then normal force, that is equal to weight of the object, mg. Okay, where m is the mass, mg means the weight of the object, weight. Okay, so if the object is on a horizontal surface, for example, there is a table here, and if this calculator on this table, the table is a horizontal surface like that, then normal force is equal to the weight of the calculator. So if the object is on a horizontal surface, the normal force is equal to its weight. Weight means mg, mass multiplied g. The value of g is 9.81. So that is the first equation. Here mu is the coefficient of friction. That is the property of the surfaces in contact that will be usually given in the question. Then next, if the object is at rest, or the object is moving at a constant speed, moving at a steady speed. So in the question it is given like that. For example, we have this equation: frictional force is equal to the applied force. Okay, applied force, I will write FA for applied force. Okay, frictional force is equal to the force you are applying on the object. Applied force, frictional force is equal to applied force when, if the object is not moving, you are applying the force but the object is not moving. If the object is not moving, or the object is moving at a constant speed, object is moving at a constant speed. Constant speed, sometimes they will give us steady speed. Steady speed. So if the object is moving at a constant speed or steady speed, or the object is at rest, then frictional force is equal to the force you are applying, the force the person is applying to move that object. Then number 3, another equation to calculate force of friction, that is force of friction is equal to applied force minus mass multiplied acceleration. If the object is accelerating, means acceleration is given in the question. Okay, if object is accelerating, if the object is accelerating, then you can calculate friction using this equation: frictional force is equal to applied force minus mass multiplied acceleration of that object. M is the mass of the object. So these are the three equations to calculate friction. And here I forgot to add one more thing here. For example, if the surface is not a horizontal surface, if the surface is an inclined surface like this, okay, if the object is on an inclined surface like this, so normal force will be normal to the surface, always normal force. And this is an inclined surface, and theta is the angle of inclination. So if the object is on a surface like this, on an inclined surface, normal force is equal to mg cos theta. So on a horizontal surface, normal force is equal to mg, and on a inclined surface, if the surface is inclined surface, normal force is equal to mg cosine theta. So these are all the equations to calculate frictional force. Different equations we have to use according to the different questions, means different context of the question. Now I will erase this and we will discuss the questions that is given in the textbook. I will write all the equations to calculate friction this side, and according to the question we will select one equation and solve the question. So first one, frictional force is equal to coefficient of friction multiplied normal force. We will use this equation if we know coefficient of friction and normal force. Mostly normal force will not be given, but they will give mass. If mass is given, normal force is equal to mg if the surface is horizontal. Okay, so we will use that, or if the weight is given, we will use this equation. Number 2, frictional force is equal to applied force. What is Fa? Applied force. So this equation we will use if the object is at rest, moving at a steady speed, steady speed. Okay, and if the acceleration given, we will use this equation: frictional force is equal to applied force minus mass multiplied acceleration. So these are the different equations to calculate friction. Now we will discuss the question. You want to move a 41 kilogram bookcase. Question number 19 from the page number 127 of your textbook. Mass of the object is given. What is the mass? You want to move 41 kilogram bookcase to different place in the living room. So mass of the object is 41 kilogram. Mass of the object is given. If you push with a force of 65 Newton, so the applied force is given. 65 Newton. You are pushing with a force of 65 Newton, and the bookcase accelerates. Acceleration also given. Acceleration is 0.12 meter per second squared. What is the coefficient of kinetic friction between the bookcase and the carpet? So you need to calculate the coefficient of friction. You can calculate coefficient of friction only if you know friction. See, coefficient of friction is there only in this equation, right? Only in the equation 1 there is coefficient of friction. Mu is coefficient of friction. You can calculate that if you know only friction. If you know friction, then only you can calculate coefficient of friction. So to calculate coefficient of friction, friction is not given here. So first you have to calculate friction. So how to calculate friction? Acceleration is given, right? In any question, if acceleration is given, this is the equation to calculate friction. So first we will calculate frictional force. Frictional force is equal to, we know that in this question acceleration is given. So we will choose this equation. Applied force minus mass multiplied acceleration. Applied force is 65 Newton minus mass is 41 kilogram. Acceleration 0.12, right? 0.12. That is equal to 65 minus 41 multiplied 0.12, that is equals 60.08. Force of friction is 60.08 Newton. Now we know force of friction. So I will choose this equation to calculate coefficient of friction. Force of friction is equal to coefficient of friction multiplied normal force. Again, normal force is not given. We need to calculate normal force. So the surface is a horizontal surface, right? You want to move a bookcase on a horizontal surface. So if the surface is horizontal surface, normal force that is equal to mg, right? And if the surface is a inclined surface, normal force is mg cos theta. So instead of normal force, we will write mg, or first you can calculate normal force and you can substitute here. So what is coefficient of friction? Coefficient of friction is rewriting this equation, okay? Frictional force divided by normal force. That is equal to frictional force we already calculated, 60.08. And normal force is equal to mg, right? M is mass, g is 9.8, mass is 41. So 41 multiplied 9.8 equals 60.08 divided by 41 multiplied 9.81 equals what? 0.149. So coefficient of friction is 0.15. What is the unit of coefficient of friction? No unit. Coefficient of friction has no unit. Why no unit? Because coefficient of friction is the ratio of frictional force to the normal force, right? It is the ratio of two forces. Here the unit will be Newton. Here also unit will be Newton. Newton cancelled. Coefficient of friction is a unitless quantity. No unit for coefficient of friction. Okay, done. Another question from friction. A block is resting on a rough surface. The coefficient of static friction between the block and the surface is 0.2. The normal force acting on the block is 50 Newton. What is the maximum static friction that the surface can exert on the block? So what is given here? A block is resting on a rough surface. The coefficient of static friction is given. Coefficient of static friction between the surfaces is 0.2. The normal force acting on the block is 50 Newton. Normal force is directly given, 50 Newton. What is the maximum static friction that can act, right? So maximum static friction, we need to calculate the static friction. So what is the equation to calculate maximum static friction? Same equation, okay? We know the normal force, we know the coefficient of friction. So static friction is equal to normal force multiplied, coefficient of friction multiplied normal force, 0.2 multiplied 50, that is equal to 10, right? So 10 Newton is the answer. Ahmed is pushing a wooden box with a weight of 500 Newton across a wooden floor at a constant speed. So Ahmed is pushing a wooden box with a weight of 500 Newton. So here weight is given. That is 500 Newton. Weight means what? Weight means mg, right? So mg is directly given as 500 Newton. Across a wooden floor at a constant speed. So it is moving at a constant speed. He exerts a force of, the force he applied, he is exerting a force of 200 Newton. What is the coefficient of friction between the box and the floor? We need to calculate the coefficient of friction. So there is a block here. This block is on this floor. Ahmed is pushing the block. Ahmed is applying a force. How much force Ahmed applying? 200 Newton force Ahmed applying on the block. What is the weight of the block? The weight of the block is 500 Newton. 500 Newton. So normal force will be how much? Normal force will be always equal to weight 500 Newton, because surface is the horizontal surface. So it is moving. Ahmed is pushing it at a constant speed. That is given in the question, at a constant speed. If there is a constant speed, which equation you have to use? Constant speed. Friction is equal to applied force. But you don't have to calculate friction, right? You have to calculate coefficient of friction. So coefficient of friction is in this equation. And we discussed already what? That if you want to calculate coefficient of friction, first you have to calculate friction. You can calculate coefficient of friction only if you know the value of friction. So what is the value of the friction? If the object is moving at a constant speed, friction is equal to applied force. If the object is moving at a constant speed, the friction is equal to applied force. So what is friction? Friction is equal to applied force, because the block is moving at a constant speed. How much force Ahmed applying? 200 Newton. So friction is equal to 200 Newton. How to calculate coefficient of friction? We will use this equation. From that equation, coefficient of friction is equal to force of friction divided by normal force. Force of friction how much? 200. Normal force how much? 500. 200 divided by 500. 0.4, right? So it will be 0.4. So always when you calculate coefficient of friction, you will get a value, a number that will be less than 1. Coefficient of friction will be always less than 1. And one more thing, coefficient of friction, no unit. Unitless quantity. Question 5. Determine components of a vector in Cartesian coordinate system using trigonometry. Okay, so we have a vector here. So we will draw a Cartesian coordinate system. So in a Cartesian coordinate system, this is our plus x, this is our minus x, plus y, minus y. So here we have a vector here, a vector. So this vector, it is a force. I will write F to represent the force. And here we have like this. For example, this is 2, 4, 6, just like that, 0 here. And this is our y direction. We have 2, 4, like this. So every vector we can divide into x component and y component. Every vector, you can see this vector f, this force f, it is not along the x direction, not along the y direction. It is in between x and y. So it has both x and y. It has, means a part of it is x and a part of it is y. So f is a combination of this force is a combination of force along the x direction and force along the y direction. So dividing a force into its x component and y component is called resolving a vector. Dividing a vector into its perpendicular components means x component and y component, right? X and y are perpendicular. So dividing a vector into perpendicular components is called resolving the vector. Resolving vector, or we call vector resolution. So what is vector resolution? Vector resolution is splitting or dividing a vector into perpendicular components. Vector resolution is dividing a vector into its perpendicular components. That is called resolution of the vector or resolving a vector. So what is the x component of this? For example, I will draw 6 little bit here. Okay. So here, to know the x component, so x component will be along the x direction, right? Yeah. So to know the x component, from here go to the x-axis. From here go to the x-axis. So what is the x component? X component we will represent by Fx, that is equal to 6 Newton. What is the y component? To know the y component, from here go to the y-axis. 4, we will make it here, 4. Go to the y-axis. So you will get y component. So how much is Fy? Fy is equal to 4. So now we know the Fx and Fy, the x component and the y component. So if you know the x component and y component, we can calculate this force. This force is not given here, right? How much is the value of the force? Do you know? How much is the value of this force? There will be a question to calculate the force. You don't know the value of the force, it's not given. But from here, if you go to the x-axis, you will know the x component. If you go to the y-axis, you will know the y component. From here, go to the y-axis, y component. So if you know the x and y, if you know the two perpendicular components, you can calculate f using Pythagorean theorem, square root of fx square plus fy square, that is equal to square root of fx 6 square plus 4 square. How much? Square root of 6 square plus 4 square equals 7.2 Newton. So this is equal to 7.2 Newton. That is the value of that force. So you can calculate a force if you know its x component and y component by using Pythagorean theorem. The force is equal to square root of the x component plus square of the y component, Fy squared. The next day, here we have a Cartesian coordinate system, for example. Yes, like this. So this is our positive x, negative x, positive y, negative y. Okay, and we have a vector here, So this vector, for example, it is a 8 Newton, for example, 8 Newton force or 8 meter per second velocity, anything, and this angle is given. This angle is 30 degree, for example. Where did I get the angle? No, just for example, 30 degree. So, but these values are not given, okay? These values on the x not given, values on the y coordinate is not given. So, we know that this vector is in between x and y, right? This is not along the x direction, not along the y direction. So, this 8 Newton force is acting in between x and y. So, it has both the force along the x direction. A part of it is along the x direction, a part of it is along the y direction. This is actually a combination, right? It is means x force along the x direction and force along the y direction combined together. So we need to divide into its x component and y component. Before, how did we divide? Before, values were given here. So we move it like this, right? From here, move to the x-axis. From here, go to the x-axis. We got the, but here values are not given. From here, go to the y-axis. Values are not given. How to get the x component and y component? Use trigonometry. Use what? Trigonometry. Use trigonometry. What is the spelling? Trigonometry. Okay, trigonometry. So what is the x component? X component, for example, this is our force Fx. F is equal to 8 Newton, right? The given force is equal to 8 Newton. So how to calculate the x component of this force? X component means component along this direction, right? This is x component, Fx, that is equal to the given force is 8, right? 8 multiplied cos this angle. Given angle, how much is the given angle? 30 degree. So the component along the x direction is cos. Use cos. How to calculate the Fy? This component of this force, part of this force along the y direction. The given force, that is 8 multiplied, instead of cos, sin 30. Then use your calculator. 8 multiplied cos 30, that is equal to 6.928 Newton, and Fy 8 multiplied sin 30, that is equal to 4 Newton. 8 multiplied sin 30, 4 Newton, because sin 30 is equal to 1 by 2. Okay, so now we know Fx and Fy, right? So we will check. If we find the resultant of xf and xy, x component and y component, we will get 8 Newton. That we will check. So this f must be equal to 8 Newton, right? Square root of 6 means square root of Pythagorean theorem, fx square plus fy square. Just checking, okay? Just checking whether our answer is correct or not. So fx how much? 6.928 square plus Fy 4 square, which equals square root of 6.928 square plus 4 square, getting 7.9999, like that. So it is 8 Newton. So we can, what I want to tell in this is a vector that can be divided into its perpendicular components. Perpendicular components means x component and y component. That is called, that process of dividing a vector into x component and y component is called resolution of the vector or resolving a vector. So how to calculate the x component and y component using trigonometry? X component is equal to the given force, the given vector multiplied cos the given angle. Y component is equal to the given vector multiplied sine the given angle or sine of the given angle. Question number 6, use free body diagram to compare the direction of the object's acceleration with the direction of unbalanced force exerted on the object. Question number 6. So for example, if we draw a free body diagram like this here. So in a free body diagram, we represent the system by a dot. So what does the dot represent in a free body diagram? It represents the system. Arrows represent the force. For example, like this. Force of gravity is acting downward. A skydiver is falling. An object is falling. For example, you are dropping a ball. So there is an upward force acting. For example, it is the air resistance or it is the upthrust acting here. So upthrust, buoyant force. So here there are two forces acting, one upward force acting, one downward force acting. Which force is greater? The downward force is greater than the upward force. How do we know? We know from the length of the arrow. The length of the arrow represents the size of the force, the magnitude of the force. Downward force is greater, right? So Fg greater than the upward force. So will there be net force? Yes. Opposite forces are not equal, right? If opposite forces are not equal, there will be net force. So there is F net, right? There is a net force. Net force is not equal to 0. There is net force. In which direction? Net force will be always along the direction of the greater force. Here the greater force is in the downward direction. So net force will be in the downward direction. Will the object be moving at a constant speed? Will it be in uniform motion at a steady speed? No. If there is a net force, right? If there is a net force, there will be acceleration. Acceleration is the child of the net force. So there will be acceleration. In which direction? In the downward direction. Why? Because direction of acceleration will be always along the direction of the net force. So what? So the object is accelerating downwards, means the speed of the object is increasing downwards, right? The object is accelerating downward. Accelerating. What is the meaning of accelerating? Speeding up. Speeding up in the downward direction, right? Downward. Okay. Suddenly, for example, the skydiver opens the parachute. When it opens the parachute, what happens? There will be drag force. There will be drag force, air resistance. So there is bigger air resistance, drag force or air resistance. I will write air resistance. Now the upward force is greater than the downward force. What is the upward force? Upward force is the air resistance plus drag, right? The up means the upthrust, the buoyant force, U, right? The upward force plus the total upward force is drag, okay? Air resistance we will call drag. The upward force is greater than the downward force. Is there what? Is there net force? Yes, still there is net force, right? Still there is net force. In which direction? There is a net force, right? Yes, there is net force. Net force is not equal to 0 because now upward force is greater than the downward force. So in which direction there is net force? There is net force in the upward direction. So will there be acceleration? Yes, there will be acceleration because there is net force. Direction of acceleration will be same as direction of the net force. So the skydiver is actually falling, okay? The skydiver is falling. The skydiver is moving down. Acceleration is in the upward direction. What does it mean? It means skydiver is slowing down. Skydiver slowing down. What happens when he slows down? Slowing down means his speed is decreasing, right? When speed decrease, what happens? Anything? When speed decrease, the air resistance will decrease. For example, you are riding bicycle. If you are riding slowly, you will feel less air resistance, right? If you ride very fast, you will feel more air resistance. If you are riding your bicycle very fast, or if you are riding motorbike very fast, you will feel more air resistance. If you reduce the speed, air resistance decreases. So when speed decreases, air resistance decreases. Air resistance means drag force, okay, drag. When speed decreases, drag decrease. Drag decrease means this force will decrease, right? The drag will decrease. Now what happened? Drag decreased, and now the total upward force become equal to the downward force. What happened? The total upward force, that is the upthrust plus drag, became equal to the downward force. Now is there net force? Upward force, total upward force is equal to downward force. Opposite forces are equal. If opposite forces are equal, forces will be balanced, right? So net force is equal to 0. If net force equal to 0, will there be acceleration? No. If net force is 0, no acceleration. Acceleration is 0. If acceleration is 0, what happens to the skydiver? Acceleration of the skydiver 0 means now the skydiver is falling at a constant speed, at a constant velocity. Skydiver is still falling, right? Falling at a constant velocity. What is the name of that velocity? Name of that velocity is terminal velocity. Terminal velocity. Okay. Terminal velocity. So there is a one good condition, okay, that we will write here. If a skydiver falling at a constant velocity, a skydiver falling, if a skydiver is falling at what? At a constant velocity. If a skydiver is falling at a constant velocity, this constant velocity is called terminal velocity. So when he is falling at a constant velocity, how to calculate its weight? The weight is equal to the upward force, okay? Total upward force will be buoyant force plus drag, right? Okay, the air resistance. So if the skydiver is falling at a constant velocity, the downward force is equal to upward force. Acceleration is equal to 0. Net force is equal to 0. Opposite forces will be equal. Let us talk about question number 7. Question number 7. Combine forces to find net force acting on an object. Okay. In that question, in question number 7, we have to discuss question number 34, 36 and 37 from page number 105, 34, 36, 37 from page number 105 of the textbook. So question number 34 is about interaction pair. So first we will talk about the interaction pair. Interaction pair. So interaction pair is from Newton's third law, right? It is from Newton's third law. Newton's third law. What is Newton's third law? Newton's third law states that for every action there is always equal and opposite reaction, right? For every action there is always equal and opposite reaction. There is always equal and opposite reaction. So this action and reaction are called interaction pair. Action and reaction are called interaction pair. So what are the similarities and differences between action and reaction? How action and reaction are similar and how are they different? So first we will talk about the similarities between action and reaction. Similarities, how they are same and how they are different. So differences, right? Yes. Similarities and differences. So what are the similarity? Action and reaction will have same magnitude. If action is 2 Newton, reaction will be 2 Newton. For example, if I push this whiteboard with a force of 10 Newton, action, the board will push me with equal force in the opposite direction, with a 10 Newton force in the opposite direction. So action and reaction will be of same magnitude, right? Equal magnitude. Equal magnitude. I am pushing the whiteboard, so the reaction will be also a push. The whiteboard will push my hand. If I am pulling this wire, so the wire will pull me in the opposite direction. I am pulling the wire is pulling me in the opposite direction. If action is a pull, reaction is a pull. For example, this water bottle, earth is attracting this water bottle in the downward direction. The force is gravitational force, right? Gravitational force, a non-contact force. What is the reaction? The reaction is the bottle is attracting the earth in the upward direction. That also non-contact force, gravitational force. They are same type of force, right? Action and reaction will be of same type. Same type. If one force is a push, other force will be a push. If one force is a pull, other force will be a pull. If one force is a magnetic force, reaction will be magnetic force. If action is the gravitational force, reaction will be gravitational force. Action and reaction will be of same type. Then if I push the whiteboard for 2 seconds, the whiteboard will be pushing me for the 2 seconds, same time duration. If I sit on the chair for 1 hour, I am applying a downward force on the chair for 1 hour. The chair will apply an upward force on me for the same time duration for 1 hour. So action and reaction will act for same time duration. Same time. And if action is acting along this line, for example, again I am pushing this whiteboard, so in which direction the force is acting? The force is acting along this line, right? So in which direction the reaction will act? Along the same line, in the opposite direction. Both will have same line of action. Same line of action, not the direction, okay? Direction will be opposite, but it will be acting along the same line. What are the differences? What are the differences? Action will be in one direction. Reaction is in the opposite direction. So action and reaction, the interaction pair will be in opposite directions. If we take example of this water bottle, earth is attracting the water bottle downwards. Force is acting on the water bottle. What is the reaction? The water bottle is attracting the earth upward. Force is acting on the earth. So action will be acting on one object, reaction will be acting on the another object, the other object. Action and reaction means the interaction pair will be acting on two different objects. Act on two different objects. So these are the similarities and differences between action and reaction. Identify each force acting on the ball and its interaction pair in figure 20, that is question number 34 from your textbook, page number 105. Identify each force acting on the ball. So there is no ball here, I will use this duster. Okay, so what are the force acting on this duster? So there are two force acting on the duster. Okay, there are two force acting on the duster. One is earth is attracting the duster downward. Earth is attracting this object in the downward direction, that is force of gravity, one of the force. Second force, my hand will be pushing this duster in the upward direction, normal force. So this duster is experiencing two forces, right? If I draw free body diagram, one of the force is force of gravity in the downward direction, the other force is normal force in the upward direction. What is force of gravity? Force of gravity is force applied by earth. Force applied by earth on what? On duster. So it is in the question, it is ball, right? So on the ball, what is the normal force? Force applied by what? Force applied by, as a subscript I will write the agent on system. Force applied by my hand on ball. So this is free body diagram of the ball. You can see both the forces are acting on the ball, right? System is ball here, this also ball. So this is one of the force acting on the ball. This is the second force acting on the ball. There are two forces acting. For both the forces, for each forces, there will be a reaction, interaction pair. So what is the reaction of this force? Okay, we will write a reaction of this force, F. It will be of same type, right? The force will be of same type. If this is gravitational force, this will be also gravitational force. Gravitational force, F. Earth is attracting the ball downward, right? Earth is attracting the ball downward. So what is the reaction? The ball will attract the earth in the upward direction. So how to write the interaction pair? Nothing, just flip it. How to write the interaction pair? Flip it. F, no change, write F. Agent on system, right? Flip that. Here earth, so ball on earth. That is how we write interaction pair. Okay, so I will give you a easy way to write the interaction pair or to identify the interaction pair. How to identify the interaction pair or how to write interaction pair? Flip it. Flip it. Flip it. So now this one you can write your own. What is the interaction pair of the normal force? F. Now you know, right? Flip it. Ball on hand. So this is the equation. Okay, this is the equation to write interaction pair. Flip it. So question number 36, like this: a ceiling, another rope. This is 5 kilogram. This also 5 kilogram. So first rope there will be tension here, T1. Second rope there will be tension here, T2. How to calculate T1 and T2? It's very easy. First we will calculate T2. Okay, T2. Yeah. Check. What is the total mass below this T2? Below this rope, what is the total mass? Only 5 kilogram. So total mass below multiplied 9.8. 5 multiplied 9.8, 49 Newton. T1. Total mass below multiplied 9.8. What is the total mass below? This is T1, right? This is the first drop. Total mass below 5 plus 5, 10 multiplied 9.8 equal to 98 Newton. Question number 37. So here there is a ceiling and there is a rope, and here there is a block, and here another block. So this is 3 kilogram, and this is T2 tension that we need to calculate, and here we do not know this mass. That mass we need to calculate, so M1 we need to calculate, and here the tension is T1 that is given as 63 Newton. Okay, so how to calculate this? We need to calculate what? We need to calculate T2, and we need to calculate the mass M1. So first we will calculate T2. T2 is equal to mass below into 9.8. So mass below 3 multiplied 9.8 or 9.81. 3 multiplied 9.8, how much? 3 multiplied 9.8 equals 29.4 Newton. So T2 is 29.4 Newton. So T1 is 63, right? So how much will be the mass? So 63 will be, so we will check like how much of this tension is due to this mass, right? So we will calculate like this. We will find the difference. So T1 minus T2, that is equal to T1 minus T2. T1 is 63 minus 29.4. So we will get the difference. 63 minus 29.4. 63 minus, answer equals 33.6. So this 33.6 Newton tension is because of this mass, right? So we need to calculate the mass value, the value of the mass. So 33.6 divided by 9.8, which equals, divide by 9.8, which equals 3.428. So 3.43 kilogram. This mass is equal to 3.43 kilogram. Question number 8. Relate the direction of the acceleration to the direction of net force, and we have to explain figure 5 from page number 88. Figure 5, page number 88. Relate the direction of acceleration to the direction of the net force. So we have Newton's second law. Newton's second law connect force and acceleration. Newton's second law connects the net force and acceleration. According to Newton's second law, the acceleration of an object is equal to net force acting on the object divided by mass of the object. Net force acting on the object divided by mass of the object. Here acceleration is a vector quantity, it has direction. Net force is a vector quantity, it has a direction. Mass is a scalar quantity, no direction. So what is the direction of acceleration? Direction of acceleration will be always along the direction of the net force, means acceleration and net force will have same direction. Acceleration and net force have same direction. Acceleration will be always along the direction of the net force. If net force is to the right side, acceleration will be to the right side. If net force is downward, acceleration will be downwards. Now we will go to the one more thing. Acceleration of an object, according to this equation, acceleration of an object is directly proportional to net force. if net force acting on the object increases, if net force increases, acceleration will increase. When net force decrease, acceleration will decrease. Acceleration of an object is directly proportional to the net force. If net force become 2 times, for example, F net, when F net increase, what happens to acceleration? When F net increase, what happens to acceleration? Acceleration will also increase. When F net increase, acceleration will increase. When F net decrease, what will happen to acceleration? When F net decrease, means when net force decrease, acceleration will decrease. When net force become 2 times, when net force become 2 times, means 2 times means double, right? When net force become double, acceleration will be also double, 2 times. When net force become 3 times, acceleration become 3 times. When net force become half, acceleration become half. They are directly proportional, and acceleration of an object is inversely proportional to mass of the object. Inversely proportionality, that we write like this. We write acceleration is directly proportional to 1 divided by mass. What does it mean? It means when mass increase, what happens to acceleration? Opposite. Okay, inversely proportional means opposite. When mass increase, acceleration will decrease. So we will write here mass and acceleration. So when mass of the object increase, the force is not changing. Okay, for a given force, for a constant force, if the mass of the object increase, means a constant force is applied on another object, the same force is applied on another object with a greater mass. So what will be the acceleration? Acceleration will decrease. When mass increase, acceleration will decrease. Why? Because mass is acceleration is inversely proportional to mass. When mass decrease, when mass of the object is less, smaller mass, what will be the acceleration? Acceleration will be greater. Greater acceleration. Smaller mass, greater acceleration. Smaller mass, greater acceleration. Greater mass, smaller acceleration, means less acceleration. So that is about the relationship between net force, acceleration and mass of the object. Now we will go to the figure 5 in page number 88. So in figure 5, we have a graph given like this. So x-axis and y-axis. On the y-axis velocity, and on the x-axis time is given. So we have 3 lines. Number 1. So here it is given, slope of this graph is 1.5 meter per second squared. Slope is equal to 1.5 meter per second squared. Second graph I will draw with the black color. Slope is equal to 1 meter per second squared. Straight line, okay, all straight line, 1 meter per second squared slope. Then third one, what is the slope of this? Slope is equal to 0.5. Slope is equal to 0.5 meter per second squared. So this is a velocity time graph. What is slope of velocity time graph? Slope of velocity time graph is what? Is acceleration. That you can understand from the unit meter per second squared means acceleration. Slope of velocity time graph is acceleration. So for example, we will consider this graph is about one object and 3 forces are acting on that object. Okay, one object. For example, 3 different forces F1, F2, F3 are acting on this object, on an object. Okay, so this is our object. on this object. First we are applying a force F1, second we are applying another force F2, next we are applying another force F3. So which one is the greatest force? For example, when you apply F1, its acceleration is 0.5. When you apply F2, its acceleration is 1 meter per second squared. When you apply F3, its acceleration is 1.5 meter per second squared. So it's given like this. This graph is for F1, this graph is for F2, this graph is for F3. Which graph represents the greatest force? The greatest force is one with the greatest acceleration. The maximum means if the force is greater, acceleration will be greater. So which force is the largest force here, the biggest force here? F3 is the biggest. How do we know? Because it has greater acceleration, or we can say it has greater slope. Slope of velocity time graph is acceleration. The next day we will talk about same force is acting on three different masses. Same force is acting on three different masses, M1, M2, M3. Okay, so this graph means same force is acting, same force F is acting. A constant force F is acting on three different objects. So this represents M1, this represents M2, and this graph represents the velocity time graph for M3. Which is the largest mass, the heaviest, right? Which one has greatest mass, the largest mass? The one with the smaller acceleration, because acceleration will be least for the biggest mass, means the large mass. So which one has the greatest mass? M1 has greatest. How do we know? Because it has smallest acceleration when same force is applied. So this is about that graph. Now we will go to another graph. So before going into that graph, we will discuss our Newton's law again. According to Newton's law, acceleration of an object that is equal to net force over mass of the object. Net force divided by mass of the object. Acceleration is equal to net force divided by mass. So we will rewrite this equation. If you rewrite this equation, what is the equation for mass? Mass I will represent by the letter M. What is the equation for mass if we rewrite this equation? Mass is equal to F net divided by acceleration, right? Mass is equal to F net divided by acceleration. Mass is equal to F net divided by acceleration. Yes. Okay, next we will go to our second graph. The second graph is like this. We have here we have what? On this x-axis we have force in Newton, and on this y-axis we have acceleration. Acceleration in meter per second squared, and the graph is like this. So this is our graph. This is our graph. This is our graph. So first question I will give, like for example, we have some readings here: 0, 2 Newton force, or I will make it 5 Newton, 10 Newton, 15 Newton, 20 Newton, like that. And here we have an acceleration like this. Okay, so here we have 0, and here 2 meter per second squared, 4 meter per second squared, like that. Here 6, 8, it goes like that. Okay, so the question is, a graph is given. This graph is about the net force. Okay, force is net force. Net force acting on the object, or acceleration of the object against the net force acting on the object, acceleration against net force acting on the object. Question is calculate the mass, calculate mass of the object, from what? From the given graph, So how to calculate mass of the object from the given graph? We will use this equation, F is equal to net force divided by acceleration. I will take this point 15. So at 15, when net force is equal to 15, what about the acceleration? How to know the acceleration? I will go from here to the graph. From here I will go to the y-axis, because acceleration is staying in the y-axis. Acceleration is there in the y-axis. 4 is right. 4 is the value of the acceleration. So 15 divided by 4. 15 divided by 4 equals 3.75. 3.75. What is the SI unit of mass? Kilogram. 3.75 kilogram is the mass of the object. That is one thing from acceleration against net force graph of an object. One more thing from the same graph. One more thing. So we have this equation that I will write neatly. Acceleration, that is equal to force by mass. So mass is equal to net force F net over acceleration. So now we will calculate the slope of this graph. Okay, slope is always y by x. What is on y divided by what is on x? What is on y here? Who is living on the y-axis? Acceleration is living on the y-axis. So acceleration divided by what is living on y-axis? Net force is living on y-axis. F net. Slope is equal to acceleration divided by F net. What is acceleration divided by F net? We don't know. We know that F net divided by acceleration, that is mass, right? F net divided by acceleration is mass. So just invert this. Acceleration divided by F net. Invert this. What? If you invert m, it will become 1 by m. 1 by m. So what is slope of the graph? Slope of the graph is equal to 1 divided by m. 1 divided by mass of the object. So if you know slope, okay, suppose for example slope is given and the question is slope is given and the question is to calculate mass. Slope is given, you need to calculate mass. How will you calculate? Mass is equal to 1 by slope. Mass is equal to 1 by slope. So mostly you can expect a question, this one. What is the slope of acceleration against the net force graph? Slope of acceleration against the net force graph is 1 over mass. 1 over mass. If slope is given and the question is to calculate the acceleration, how will you calculate? Question is to calculate the mass. How will you calculate? Mass is equal to 1 divided by slope. 1 over slope. Question number 9. Resolve a vector into orthogonal vectors in Cartesian coordinate system. And we have some questions to discuss from page number 121. Page number 121, right? So there is 3 vectors K, L, M. Okay. So for example, if a vector, I will give a vector like this, right? A vector that is along this direction. So first we will draw the coordinate system. Coordinate system. So what coordinate system? This is the positive x, negative x. positive y, negative y. So you have a vector like this. This vector is completely along the x direction. X direction means x means horizontal. X we call horizontal. Y we call vertical. So this vector we will give a name, vector A. Vector A is completely along the horizontal direction, means along the x-axis. For example, its value is, this is a velocity 3 meters per second, or a force 3 Newton. So what is the x component of this force, or x component of that vector Ax? That is equal to 3, because it is completely along the x direction. What is the y component of this force? 0, because it is completely along the x direction. Number 1. Number 2. There is a vector that is along this direction, for example, along this direction. We will call this is another force 6 Newton. What is its x component? We will call a name. This is our vector B. So Bx, x component of this vector is 0, y, because it is completely along the y direction. What is its vertical component? The component means the part of this force along the y direction, that is 6 Newton. Why? Because it is completely along the y direction. Another vector, third one. For example, as it is given in the book, a 5 Newton force, for example, 5 Newton. So this is our C. C is equal to what? 5 Newton. This is not along the x direction, not along the y direction, but in between x and y, and it is making an angle, for example, 37 degree with the x-axis. So 37 degree from the x-axis. Okay. So what is its x component? Cx. That we cannot say 5 Newton, because it has the 5 Newton means it is x and y component together 5 Newton. So if we divide means resolve, right? If we do vector resolution, resolving the vector, dividing the vector into its x component and y component, Cx is equal to 5 multiplied cos theta. So theta is this angle, okay, that is 37, right? 37, calculate and write. Then what is Cy? Means component of this one along the y axis, 5 multiplied means this is 5, right? The given value multiplied, y component is the given value multiplied sine of the angle, sine 37 equal to what? Equal to what? 5 multiplied cos 37 equals 3.99. 3.99 Newton. 5 multiplied sine 37, 5 multiplied sine 37 equal to what? Equal to 3.0. Okay. Then next, if you have a vector along this direction, this direction, for example, this is a 4 Newton force. We will give a name D. So what is its x component? Dx. Dx is equal to, it is completely along the x direction, right? But along the negative x direction, So dx is equal to negative 4 Newton. What is dy? Dy is equal to 0. Okay. The next I will give, I am not giving the values. We will just take a positive or negative, you have to tell, okay? Yeah, we will erase all these things. I hope you understand this. Okay. So we have a vector here, number 1. We will give the name A. We will give the name A for that. So AX, is it positive or negative? From here, go to the x-axis. It is in the positive side of the x. So AX is positive. AY, positive or negative? From here, go to the y-axis. This is plus y, right? Positive of the y. So positive. We have another vector that we will draw here. B. So what is Bx? You have to tell whether positive or negative. Okay, in this example I am not giving the values. So Bx, from here go to the x-axis. It is reaching negative of the x. Negative. By, from here go to the y-axis. It is reaching positive, right? Yeah. Then another vector. Black is not writing good. Okay, so we will give a name C. What is the x component? From here go to the x-axis. Cx, tell negative or positive? Negative, right? Y component, from here go to the y-axis, both negative. Cy, right? Both negative. So if the vector is in the third quadrant, this is quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. So if it is in the first quadrant, both are positive. Third quadrant, both are negative. So here in the fourth quadrant, from means how to find the name is D. Dx, x component of D. From here go to the x-axis. It is reaching positive of x. X is positive. From here go to the y-axis. Dy, positive, right? Why did I write negative here? Positive side of the x-axis. Okay, so dy is negative, right? Negative. Okay, so this one you can expect a multiple choice question from this section. Question number 10. So we are reaching half of the EOT now. Question 10. So what is question 10? Relate graphically the frictional force to the normal force and find the coefficient of friction. So question number 10 is about friction. It is about friction. So what is the most basic thing in friction? The most basic thing in friction is equal to coefficient of friction multiplied normal force. Coefficient of friction multiplied normal force. If we rewrite this equation for coefficient of friction, so it will be frictional force divided by normal force. Correct? Yes. Perfect. So figure 12, we have to discuss figure 12. Figure number 12 from page number 122 of your textbook. Sorry, it is 123. Next page. Okay. 123. So here we have a figure. In that figure there is a graph. A graph of kinetic friction against the normal force. So here we have kinetic friction on the y-axis and normal force on the x-axis. Normal force on the x-axis. So for example, the graph is like this. If you calculate the slope, you are calculating the slope. What is slope? Slope is always what is on y divided by what is on x. Who is living on y? Kinetic friction. So frictional force is living on y. Who is living on x? Normal force. F divided by N. Friction divided by normal force. What is friction divided by normal force? That is coefficient of friction. That is equal to coefficient of friction. So what is the slope of kinetic friction against the normal force graph? Slope of kinetic friction against the normal force graph, that is equal to mu What is mu? It is coefficient of friction. Coefficient of friction. So we have three different surfaces. Okay, a ball is rolling on three different surfaces. One, a wooden table. Another one, a highly polished floor. Another one what? Another one, we have very rough surface, sandpaper, very rough surface. Okay, so here which one has greatest slope? Black one, blue one, red one. We know that, right? Just by seeing slope means the inclination. Slope, what is the slope? This inclination is the slope. Which one has the greatest slope? The black has the greatest slope, right? The one near to the y-axis, the one near to the y will have greatest slope. So this one has greatest slope, which means it has greatest coefficient of friction or greatest friction. So which graph will be sandpaper? Which one is representing wooden table? Which one is representing highly polished floor? The one that is very smooth has very less friction, right? So this one has very less friction. So this is representing highly polished surface. This one has the maximum friction, the black one. So this is the sandpaper, the rough surface. This one is in between, so we can say like the wooden table. I hope you understand this. We will go to question number 11 now. It is to calculate friction. It is about calculating friction. Calculating friction, and we have to discuss two questions, question number 15 and 16 from page number 125. Question number 15, 16, page number 125. So to calculate friction, first we have to know the equation to calculate friction. So that we have already explained these things, so I'm just repeating that. If in any questions to calculate friction, you can follow this, and if any in any other EOT question the friction repeat, we will not explain, okay, that. So we will cover that here. So what is the basic equation for friction? First equation for friction: frictional force is equal to coefficient of friction multiplied normal force. So to calculate friction, we have to know the normal force. So if the surface is a horizontal surface, normal force is equal to mg for a horizontal surface, and if the surface is inclined surface, normal force is equal to mg cos theta. Theta is the angle of inclination. So for inclined surface, okay. Another equation. So this equation you can use if mass is given, normal force is given, or weight is given, okay. So if you know the normal force, you can use this equation. If you know what? If you know coefficient of friction and normal force. If coefficient of friction and normal force is given in the question, you can use this equation. Usually normal force will not be directly given. Instead of that, mass will be given. If mass is given, you can calculate normal force using the equation mg. Number 1. So what is our second equation? Second equation is frictional force is equal to applied force. When to use this equation? You can use this equation if you are applying the force. If a force is being applied on the object is not moving, means the object is at rest. So use this equation. Or if the object is moving at a constant speed, sometimes it will be given in the question as a moving at a steady speed. So if you see these words like a constant speed or steady speed, then frictional force is equal to the force you are applying on the object or someone else is applying on the object. Then next, if acceleration is given, if the object is accelerating, then frictional force, that is equal to what? Applied force minus mass multiplied acceleration. So you can use this equation if there is acceleration in the question. Okay, now we will move to questions. Question number 15 from page number 125 of the textbook. Given what? Exerts, a name not given. He exerts a 36 Newton horizontal force as he pulls. So he is applying a force, applied force is 36 Newton. As he pulls 52 Newton sled. What is the meaning of 52 Newton sled? 52 Newton. Newton is a force, right? 52 Newton sled means the weight of the sled is 52 Newton. For example, 5 kilogram apple means mass of the apple is 5 kilogram. So 52 Newton sled means the weight means mg, right? So mg is directly given, weight is mg, 52 Newton. What else is given? Across a cement sidewalk at a constant speed. What is the coefficient of friction, right? So it is given constant speed. I will write that keyword here, constant speed, because constant speed is one of the keyword in our equation, constant speed. And we need to calculate what? We need to calculate the coefficient of friction. So I said in the last when we are discussing another question about the friction, we cannot calculate coefficient of friction if we don't know the frictional force. So to calculate coefficient of friction, first you have to know the frictional force. How to know the frictional force? In the question it is given the object is moving at a constant speed. So what? If the object is moving at a constant speed, frictional force is equal to applied force. How much force you are applying on the object? You are applying on the sled 36 Newton force. So frictional force is equal to 36 Newton. So now you know the frictional force. Then how will you calculate the coefficient of friction? You can calculate coefficient of friction using this equation. Coefficient of friction is equal to frictional force divided by normal force. Force of friction divided by normal force. You know the force of friction 36 Newton divided by, but normal force is not given. The surface is horizontal surface, right? Yeah. He exerts 36 Newton force on a horizontal surface. Surface is horizontal. If the surface is horizontal, normal force is equal to mg, the weight of the object. Here weight of the sled mg is given 52. So 52, which equals what? 36 divided by 52. 36 divided by 39, not 39, 36 divided by 52, which equals 0.7 or 0.69 unit. No unit for coefficient of friction. So if I am going very fast, you can write in the comment, because I don't want to make it more than 2 hours. I want to make the video less than 2 hours. I don't know whether it is possible or not. So we will move to the next question. Question number 16. Mr. is dragging a box full of books from his office to his car. The box and books together have a combined weight of 134 Newton. Here also weight is given. Weight is given. Weight means mg, right? So mg is directly given. If mass is given, you need to multiply that with g. Here weight is given, so we will write mg. So 134 Newton. If the coefficient of static friction between the pavement and the box, coefficient of friction also given 0.55. How hard must he push horizontally on the box in order to make it start moving, right? So you need to calculate the applied force. You need to calculate the applied force to make it start moving. To make an object start moving, your applied force must be equal to the maximum value of the static friction. What is the equation to calculate maximum value of the static friction? Same equation, no difference. To calculate the maximum value of static friction, you have to use the same equation. So applied force, how much force you need to apply to make an object start moving, that is equal to maximum value of static friction. Same thing, okay? Maximum value of static friction in the equation or in the calculation, it is the same thing, no difference. So what is this? It is the maximum static friction. So how much force you have to apply? That is equal to maximum static friction. In the question, maximum value of static friction is not given. You need to calculate that. But what is given? Coefficient of friction given. If you know coefficient of friction, which equation will you use to calculate friction? You will use the first equation to calculate friction. So friction is equal to coefficient of friction multiplied what? Normal force. What is normal force? Normal force is equal to mg, right? So coefficient of friction is 0.55, just substituting the values. Normal force is 134, that is equal to weight of the object. So 0.55 multiplied 134, which equals 73.7. So 73.7 Newton is the applied force, means that much force you need to apply to make that object start moving. Question number 12 is about the apparent weight and the elevator. So question number 12 is about apparent weight. Apparent weight and the elevator. So if we and we have to discuss one example here, example 3 from page number 97. Example 3 from page number 97 of the textbook. So when we stand, for example, if I stand on a scale, two forces will be acting on me. So for example, I am standing on the scale. So this is a scale and I am the one standing on this scale here. So there will be two forces acting on my body. One of the force, always it will be force of gravity. Force of gravity, so I will write a force of gravity Fg. What is force of gravity? Earth is attracting me in the downward direction because of its gravitational force, right? So that is force of gravity, and this force of gravity we can calculate by using the equation mg, right? Force of gravity is the mg. That is the real weight of an object. For me, for this example, that is my real weight. So this is the real weight, the actual weight, real weight. So what is apparent weight? Apparent weight means it's not the real weight, it is something else. So what is the second force acting on me? The second force is I am standing on the scale, so the scale will push me in the upward direction, right? The reaction force, normal reaction. If any object is standing or staying on the other object or on a surface, the surface will push that object upward, that we call normal reaction. So this is the second force, the normal force, normal force. So normal force, this is called the apparent weight. Normal force is called the apparent weight, apparent weight. And this is the weight the machine read. This scale that you are standing, or the scale that I am standing on it, will read. So this is the will read the apparent weight. Okay, it reads the normal force, that is the apparent weight. So this is the machine reading. This will be the machine reading. That will be the machine reading. And the force, I am feeling my weight, right? No, I am feeling my weight. I am not feeling like I am floating, weightless. So everybody feel their weight. So what weight am I feeling now? Is it the real weight we feel or the apparent weight we feel? We always feel the apparent weight. So apparent weight is the one that we are feeling. Now I am feeling my weight. So that is not my real weight, that is the apparent weight, but in most means in some situations the real weight is equal to apparent weight. Now the real weight is equal to apparent weight. Okay, so that we will check when the real weight is equal to apparent weight and when the real weight is not equal to apparent weight. To check that, what you are doing, you are taking that scale to the elevator, you are keeping the scale on the elevator and you are standing on it. Number one, the elevator is at rest, it's not moving. If the elevator is at rest, then your apparent weight and your actual weight, real weight, will be same. Means apparent weight is equal to mg if the elevator is at rest. Elevator is not at rest. Elevator is not at rest. It is moving. It is moving up or moving down at a constant speed. If the elevator is moving up or down at a constant speed, still your apparent weight is equal to the real weight. Okay, still the apparent weight is equal to the real weight. Do you understand? If the elevator is at rest or moving at a constant speed, apparent weight and the real weight will be equal. That is equal to mg. What is mg? Mass multiplied g. What is g? Gravitational field of Earth. What's the value? 9.81. Next, the elevator is moving up. The elevator is moving up. So if the elevator is moving up, there are three situations. It can be moving, it can be speeding up, it can be slowing down, or moving at a constant speed. Moving at a constant speed we already discussed. So two remaining. The elevator is moving up with increasing speed, means with an acceleration, speeding up. So here the apparent weight is not equal to the real weight. Apparent weight will be greater. Apparent weight will be greater. Apparent weight will be greater than the real weight. So how to calculate that? I said apparent weight is the normal force, right? So you can calculate using this equation. Here you can write apparent weight, or apparent weight is equal to normal weight. Normal force. Normal force is called apparent weight. That is why I am using the letter N. Okay, so how to calculate that? Using this equation, mg plus ma. What is m? Mass g. 9.81. M again, mass a, acceleration. Acceleration. So if the elevator is moving up, going up and speeding up, then you will feel your weight is greater. You will feel heavier. You will feel your weight is increased. Okay, machine reading will increase. Machine reads normal force. You feel normal force, and that is the apparent weight. Then next situation, the elevator is moving up with a decreasing speed, slowing down. So in that case, just opposite, you will feel, means apparent weight will be less than the or smaller, right? Smaller than the actual weight. So what is the equation? Nothing. N is equal to, see, if no acceleration, if there is no acceleration, apparent weight is equal to mg, right? Mg. So means if the apparent weight is less, we are reducing something from that mg. So mg minus ma. Mg minus ma. The next, down, right? Where this minus come from? Because acceleration is negative. Okay, it is slowing down, right? Acceleration is negative, that is why that here a minus comes. Okay, then the elevator is moving in the downward direction. If it is moving in the downward direction at a constant speed, the apparent weight is mg, equal to the actual weight. But if it is moving downward and speeding up, then downward and speeding up, so it will be, apparent weight will be less than the actual weight, so smaller. What is the equation? Same equation. If it is less, we need to reduce something from mg. So that something is ma, net force. What is that something? net force. Ma is the net force. Slowing down, so apparent weight will be greater than the actual weight, more than the actual weight. So what is the equation? Apparent weight is equal to the real weight plus something. What is that something? Something is mass multiplied acceleration. So this is the equation for different situations. Now we will discuss one example, right? The example problem 3 from the textbook. So I will erase all these things. Your mass is 75 kilogram. So your mass is given. Mass is equal to 75 kilogram. And you are standing on a bathroom scale in an elevator starting from rest. The elevator is accelerating upward. So the elevator is moving up with an acceleration 2 meter per second squared, 2 meter per second squared for 2 seconds, and then continues at a constant speed. After that, constant speed spelling is wrong. Anyway, after that, is the scale reading during the acceleration greater than, equal to, or less than the scale reading when the elevator is at a rest? So the scale reading, we need to check greater, less, or equal than the scale reading when it is at a rest. So that is the question. Without calculation, that we can tell whether it is less or more. And as the values are given, we will do the calculation also. If there is question to calculate the apparent weight, you can use that equation and you will calculate. Okay, so here the elevator is moving up and accelerating, right? So only one thing you can remember: moving up and accelerating, moving up and accelerating, speeding up, right? Moving up, speeding up. Elevator moving up, speeding up, moving up, speeding up. Both are up, moving up and speeding up, right? Both are up. If both are up, it will be greater. Moving up and speeding up, then apparent force will be greater, means apparent weight will be greater. Apparent weight will be greater. So I will choose this because moving up and speeding up. So what is the equation? While moving up, speeding up, the equation is apparent weight is equal to mg plus ma. So mg plus ma, m is 75 kilogram, g is 9.8, 1 plus m again 75 kilogram, acceleration 2, right? 2. So 75 multiplied 9.81 plus 150, right? 150, which equals 885.75. 885.75 Newton, that is the apparent weight. What will be his actual weight? If he calculated the actual weight mg, so 75 multiplied 9.81, right? So actual weight will be only 735, right? Actual weight is 735.75 Newton. So you can see the apparent weight is greater than the actual weight. So moving up, speeding up, right? The next day, moving down, slowing down, moving down, slowing down. In moving down, slowing down, both are down, right? So if both are down, moving down, slowing down, so here also apparent force will be, means apparent weight, right? Apparent weight will be greater. See, both up, greater, both down, greater. I will give you another one. moving up, but slowing down, moving up, slowing down. One is up, other is down, right? One is up, other is down. So apparent weight will be less than the actual weight. Here also, moving down and moving down, speeding up, moving down, speeding up. So apparent weight will be less than the actual weight. So you can remember like this. If both are up, apparent weight will be greater. If both are down, apparent weight will be greater. If one is down, one is up, apparent weight will be less. One is down, one is up, apparent weight is less. Next question, question number 13, that is about inclined plane, and we have to discuss some questions from the page number 131 of the textbook. So inclined plane, it is a very easy topic. So first what we will do, we will draw an inclined plane. This is the horizontal and this plane is our inclined surface or inclined plane, and this plane is making an angle theta from the horizontal or with the horizontal. So this angle is called angle of inclination, that we will represent by theta, and here there is an object here. An object is resting on this inclined surface. So mass of the object will be usually given. So we will write mass of the object is m. M is the mass of the object. So first what you have to do, we will draw a dot here and we will draw 4 lines. 1, 2, 3, 4. It's very easy. What is this one? Each arrow represents force. So what is this force? This is mg cos theta. What is this one? mg sin theta. This one, force of friction. What is this? Normal, right? Perpendicular. Perpendicular to the surface or normal to the surface, that will be always normal force. Okay. So this is all about inclined plane. You draw this, you will know everything about inclined plane. So we will do the questions. Okay. Before that, before going to the questions, we will form some equations here. If this object on the inclined plane, that block on this plane, if it is at rest or moving at a constant speed, this rest and constant speed is all same thing. Every time it is same, right? Rest and constant speed is always together. So rest and constant speed, every equations will be same for both of this. So if the object is at a rest or at a constant speed, or before that I will tell one thing. Before this one, I want to add one point. This normal force will be always equal to mg cos theta. Normal force will be always equal to mg cos theta. Why? Because this block will not move in the upward direction. It will not move into the plane. So it does not have motion along this direction, motion along this direction. So normal force on an inclined surface will be always equal to mg cos theta. Then next we will give conditions here. So this one done. Normal force always equal to, without any condition, always equal to mg cos theta. Then I am talking about these two forces. If the object is at rest, or moving at a constant speed. If object is at rest or moving at a constant speed, which means acceleration is 0, right? Acceleration is 0 means F net is equal to 0. F net is equal to 0 means object is in equilibrium. Object equilibrium means opposite forces are equal. If the object is at rest or moving at a constant speed, always opposite forces are equal, if the object is moving at a constant speed or at rest, opposite forces will be always equal. What are the opposite forces? Here normal force is opposite to mg cos theta, but that we already done, right? Frictional force is opposite to mg sin theta, so frictional force that will be equal to mg sin theta if the block is at rest or sliding down at a constant speed. The next, what is the other situation? Other situation, it can be it is sliding with an acceleration. So if the block is sliding down with acceleration, with an means speeding up, right, with an acceleration, in that case frictional force is equal to this is the force which caused the motion, right, mg sin theta. So mg sin theta minus mass multiplied acceleration. So this equation you can use if there is acceleration. If there is acceleration, then mg sin theta means frictional force is equal to mg sin theta minus ma. So what is the basic equation for frictional force? The basic equation for frictional force is coefficient of friction multiplied normal force, that is equal to mg, I wrote mg sin theta, right, mg sin theta minus ma, mg sin theta minus ma. So this is equal to, sometimes the question will be to calculate the coefficient of friction. So how to calculate coefficient of friction? mg sin theta minus ma divided by mg sin theta minus ma divided by what? Normal force. What is normal force? Normal force is always equal to mg cos theta. So these are the equations you can use to calculate the to calculate different things in the questions from the topic inclined planes.